Hidden behind an ordinary house in rural Ireland is a breakthrough project which began in Trinity College, Dublin. SolarCool is participating in Science Foundation Ireland's Zero Emissions Challenge. So we're here in Louth, and just over here is a really innovative project, and they're looking at the future of solar panels. It's just fascinating that this kind of science is happening, surrounded by fields and sheep and cows, and I'm really excited to get in and see what they're up to. David, this is really great. What am I looking at?
So this is our solar test site here, and what we've done is we've taken the latest technology in solar panels, but the ones that are actually commercially used in solar farms, and we've taken a few different types, and also we've mounted them in the ways that they would be mounted in solar farms and on rooftops and commercial, just to compare them. For our project, we're focusing on the temperature of the panels, which is something people don't usually look at. So we've put a lot of sort of temperature sensors and test equipment in here that usually wouldn't be on a solar farm.
So David, always interested in the simplest explanation possible. So how would you explain it to a 5-year-old or to me, a social scientist?
These solar panels, they collect energy from the sun and convert it to electricity, but they're not 100% efficient at doing that. There's only 20% efficiency of the panel. And the rest of that energy actually heats the panel up. So during the day, these panels can get up to about 55 degrees C. And the problem is that their efficiency, or the conversion to electricity, gets worse the hotter the panel gets. So it's this kind of catch-22 problem that the more solar irradiation you have, the lower the efficiency is.
So this is kind of a normal day in Ireland. It's a little bit chilly, the sun is shining a little bit. And you're saying even in these conditions, it can get up to 50 degrees, 55 degrees C.
We're just constructing these panels at the minute, but you can actually feel, even today, it's a very cold background, but if you put your hand on the panel, you can feel that there's a little bit of heat there.
Oh yeah, it's lovely.
So we're just coming out of the winter here. It's 6 degrees background temperature, but this might be 25 degrees. So there is a big difference between the panel temperature and the background temperature. And so what we're trying to do here is to just keep the panel temperature down, but we're trying to do it in a way that could be scaled to a solar farm, which might have 100,000 panels. In some of the countries that we're looking to work in, like Saudi Arabia, these panels can get up to 95 degrees C. And what happens when they get hot is they start to degrade faster. So a normal solar panel will have a 25-year lifespan, but if it's operating at those temperatures, it could be in 10 years. If you look at how panels are designed, from a heat perspective, they're very badly designed because they're basically a greenhouse. You've got glass in the front, glass in the back, and they trap the heat and they don't let it out. So we produced a technology which can help let the heat out, and it brings down the temperature, the electricity output goes up, and the lifetime extends.
Can I see SolarCool, your technology? Is it hidden in plain sight?
So unfortunately, the stage we're at today, you can see here there's a gap where there's no solar panels. So that's where our prototype was. And the stage we're at with the project now is very IP sensitive. It's very important that we don't disclose exactly how it works.
So I'm standing where your technology normally sits. Can you even describe it? Is it incredibly complex, kind of heavy physics, heavy engineering?
Unfortunately, no, it's not complex at all. And we started with the most complex thing we could think of, because we're physicists and we had carbon nanotubes and we had these wonder materials. And then we just looked at the costs and we said, well, you know, the solar panels only cost 100 euros. We can't have a technology that costs 100 euros, or you just buy another panel. But it became a really interesting challenge to be like, well, how cheap can we make this? You know, how can we reduce the material? And that drove us to a very simple design.
Is the technology you've created, the SolarCool technology, is that retrofittable to existing panels, or is it something that has to kind of get assembled onto the panels when they're leaving the factory?
So we're looking at both options, but what we're really excited about is we are the only people targeting existing solar farms to have something that could be put onto solar farms. Solar farms in Europe are only about 12, 15 years old now, and they're meant to last about 25 years, and nobody really knows what's going to happen at the end, because at the end of life, after 25 years, they're still 80% efficient. They're still outputting 80% of the power they were at the start. And a big part of our project is going to be looking at redistributing and reusing what are called end-of-life panels. So we think by applying our technology to panels that are coming from these solar farms, we could redistribute these to places that need energy, people that need these solar panels at a very low cost.
SolarCool is already working with Concern worldwide with the aim of getting solar energy to places where it is vitally needed in the developing world.
We work a lot with frontline clinics, for example. So if you can imagine these very weak health services, you got these very small clinics, 20, 30 miles from the nearest town. They don't have energy. You know, how do you have a cold chain? How do you store drugs, the essential drugs, to serve a local population when you don't have a cold chain, a fridge to keep those drugs cool? And that's exactly why a project like this can really benefit those kinds of remote clinics or remote schools, again, that don't have, they're all off grid. So we think very much about supporting local health systems, local government systems, about delivery of services. They need energy, and again, solar panels, solar energy is really one of the real potentials to be game changers in that regard. And this is where working with the private sector, and for, you know, like SolarCool to be working with partners in Africa, for example, who are private providers of solar panels, getting them down to be as cheap as possible so that they are affordable in remote rural areas. That's the secret to it. That's when it'll really take off.
What's the big vision for SolarCool?
For us, it's all about getting international impact. You know, we're here in a small garden in Ireland, but we are demonstrating a technology which could double the lifespan of solar panels or solar farms. And to really show that, we need to go to real solar farms in global areas that are quite hot and arid. So the vision is really to get out there over the next year or two, to really get out there internationally. We work with Phelan Energy Group, and Phelan Energy have a number of solar farms in South Africa and India that we're looking to deploy on. And in particular in South Africa, their solar farm is the largest in the Southern Hemisphere. So it's really large-scale solar farms. And the idea with working with Concern and Phelan is that we can show developers like Phelan that there is a route to collaborate with charitable organisations to redeploy end-of-life panels, refurbish them and redeploy them where they're needed. And really all that needs to happen there is for us to show that logistically this can work. And it's a very exciting prospect to travel the world, to see these solar farms and to really, you know, make a difference in some people's lives.